and hit record. All right. And so discount, I think we all know what that is, but I'm just going to go ahead and define it anyways. So discount is nothing more than discount is the and this is just a loose definition here. So it is the amount that a product is reduced by for purchase. Okay? Now, when we think about how a company prices something, honestly, this is exactly what happens, all right? So let's say, for example, we have an object, I don't know, let's say a controller. Let's say a PS5 controller. Oh, and I wrote PS4 like a dummy. All right, so you got a PS5 controller, okay? And let's just say, for example, and this is going to make our math kind of easy. Let's just say the price is $50, okay? Now that means 100% of this price is $50. That's what that bar represents. That bar represents the height of $50, okay? When we say something goes on sale, what they're doing is they're cutting the price down. Just like if I were to cut right here. So this piece right here could represent 10%, which means this is going to be $5, and down below represents $45. All right, now I did that math real quick in my head, okay? But when they say, or when you go to the store and they say, hey, you know, the original price of this controller is $50, but we're going to sell it to you 10% off, that's our discount, then they're taking part of what they thought it's worth and they're just discounting it by 10%. In this case, you were going to save $5. You're going to pay $45. So, like I said, if you think about this, then give me 1 second here because I'm going to shade. Then the yellow portion represents 10%. And then the blue part would be the amount or the percentage left over. That's what you're paying. So you're going to be paying 90% of what it's worth. Okay? And that's exactly how discounts work. So if you think about it in terms of that, there are multiple ways to do discount problems. You could find the amount of discount and then subtract it from the original price, or you could take the percentage of what you're actually going to pay and just multiply that times the purchase price. So let me go ahead and give you some formulas here. And these are the last two formulas of the semester. So I'm going to write the word discount and sale price. And here are the formulas. The amount of discount is going to be equal to the discount rate times the original price. Okay? And then the sale price is going to equal the original price minus the discount. So, like I said, if we were to take this example and how I did it, like I did it in my head a little bit, here's what I did. First thing is I found the amount of discount. The store is telling me that they're going to sell me this PS5 controller for 10% off. So my discount rate is going to be 0.1 times the original price, which is $50. Now, remember, you're multiplying by a factor of 10, such as 0.1 or 0.01. So all we have to do is count the number of decimal places and move our decimal place one place to the left. So the amount of discount equals $5, or just 5. Okay? Part 2 is, well, the sale price then is going to equal the original price minus the discount, or $45. Okay? Are there any questions there? All right, let's just do an example then. So,
I want to ask, is this the same as like clearance? Like if you go to the store,
yeah.
Like clearance deals. Okay.
So the difference between a discount and a clearance is a very discounted item. Like you know what I mean? Like normally discounts are like, and Leah, the only reason why they do that is to make it sound like it's a better deal, which it is. It totally is. But if you think about it, what sounds better? Discount or clearance? I mean, clearance even it has the word clear in it. Get rid of it. Clear it out. Let's sell these things. So, it all depends. Excuse me. It all depends on what store you go to and how they define a clearance. That's where normally that's the first place I go when I go shopping for like clothes. I go right to the clearance. I don't care if it's not in season. Fashion doesn't mean anything to me. I could care less. My wife, on the other hand, she likes to have some nice things every once in a while. So, but me, I go right to the clearance rack. All right, let's look at an example here. So, a discounted or discontinued washer and dryer combo is advertised on sale for 35% off the regular price. Of $700. Find the sale price and discount. Okay? Now, just a little shopping tip for those of you who, eventually want to move out and get your own house or something like that. You could save a lot of money by looking for special deals, like things that are on discount or clearance, but also you can find items that are like dented on the side or the paint is scratched, and you can get a really big discount on items like that. The only thing is, are you comfortable with having a dent or, a paint chip missing from your appliance? Now, if you have like a refrigerator that goes into like a little spot in the house where all you see is the front of the fridge, then I'd look for a dented one. Save yourself some money. They're still fine. They still have all the warranties and everything. It's just dented on the side. But that's up to you. I'm just throwing it out there. Because sometimes people don't even know that you can do that. It's out there.
Doing that.
What's that, Mike?
I said I saved like $400 doing that with a fridge.
Perfect. Yeah. My
Yeah, it's worth it.
Oh yeah. My dad did that with his refrigerator as well. I think he saved around $400 or $500, and it was dented in the back of the fridge, so you would never see it. But he bought it anyway, or he bought it anyways. I can't believe it was even on the floor that long, because I would have bought it. But anyways, let's go ahead. Let's do this problem now. Remember, we want to find sale price, and in order to do that, we have to find a discount first. So we got to do the discount first. So the discount is going to equal the discount rate, so they're telling us it's 35% off. So remember, we need a decimal for that. And we have to multiply that times the original price, which is $700. Now, this will tell me how much money off I'm going to get. So, I'll come over to the right here, and I'm just going to multiply. 5 times 0 is 0. 5 times 0 is 0. 5 times 7 is 35. Put a 0. Now I'm going to do the 3. 3 times 0 is 0. 3 times 0 is 0. 3 times 7 is 21. Now I have 0 decimal place in the first number, 2 in the second number for 2 decimal places. So my discount equals $245. So that is a big discount. I mean, that's huge. $245 off. That's massive. So now that we found the discount, we can go ahead and find that sales price just by taking 700 and subtracting 245 from it. So once again, I'll come over here to the right and I'll just set up my problem. I need to borrow. 10 minus 5 is 5. 9 minus 4 is 5. 6 minus 2 is 4. So my sale price is equal to $455. Does that make sense, everyone? How are we looking? Pretty good? Any questions? All right. Well, congrats. That's it. Semester is over. We are officially done with all the material. How do you feel?
Tired.
Tired. Savannah, I agree with you. I'm not going to argue that. All right. So, I'm going to go over a review now, okay? The next time I see you is going to be on Monday, which is our official last class. So whatever we don't do today, I'm going to just pick up on Monday and do as much as I can. All right? Just to reiterate. Sorry, I was looking for Artie real quick. Just to reiterate. All of the homework for the entire semester is due on May 14th. I reopened every single homework assignment for you. So if you want to do it, if you want to do them over again to get a higher score, go for it. If you have missed a quiz or a test, you got to talk to me. All right? You have to talk to me on the side, which means email me or stick around after class. All right? We'll figure something out. The review for the final has been posted since last week. All right? It is in my math lab. And it is a review. It doesn't count towards your grade. But if you can get through the review pretty decently, I'm not saying get everything right, but if you can get through the review, then you're going to be more than prepared for the final exam. The last thing, when is our final exam? Well, let's see here. So, we go, what's that?
The 12th.
The 12th. I believe you. I always go over this. And I'll go over it next week as well. What are we? SC01? Yeah. That's us. So our final exam is Wednesday, May 12th. From 10:30 to 12:30 p.m. All right? Are there any questions?
So, do we log in on Zoom at that time?
Absolutely.
Okay.
All right? There's already like a Zoom class there. Even like so somebody brought this up today and I always forget to mention it. But you know, if you go through Blackboard and click on the Zoom thing, there should already be other classes there. Just on Wednesday, or what day is it again? The 12th? I already forgot. Yeah. So a week from today, just sign into Zoom. The final exam it'll appear at about 10:25. Like I open up like 5 minutes early. And if you have any questions, you can unmute yourself, ask me. Once you're done, you're done. That's it. So, do you have any questions for me before we go on? All right. I don't hear anybody talking. No questions. So here is our final exam review. All right. So, overall, here's what we did. Chapter 1, add, subtract, multiply, divide whole numbers. We also learned how to round. Chapter 2, we did the same thing. Add, subtract, multiply, divide, except we did integers. All right, which are those sign numbers. So remember your rules for the sign numbers, okay? And we're going to do problems. Don't worry. It's not like I'm just going to write this and go away. All right? Big emphasis here was the order of operations. Chapter 3 was very small. It was very short. All we did was solve equations. Okay? Chapter 4. Add, subtract, multiply, and divide with fractions. And everything that we see in chapters 1, 2, and 3, we did in chapter 4. So we rounded, we order of operations, we solved equations. Most important part here would be adding, subtracting, multiplying, dividing, and solving. Remember those steps. Chapter 5, add, subtract, multiply, divide with decimals. And then chapter 6. Chapter 6, we learned about ratios, portions, converting between decimals, fractions, and percents. We also did sales tax, commission, and discounts. So when you think about it, we did a lot. Okay? So I'm going to give you a minute to write that stuff down, and then I'll get started with our review. Now, on your practice final, there are 60 questions. Obviously, my questions are going to be different from your questions. I'm not going to have time to do all 60, but I will do all the important ones. Okay? And every single question, you're going to be able to, you'll be able to relate back to what I just wrote. So, oh, I hear somebody. Let me mute. There we go. So here we go. Actually, let me just write. Review. So here's our first problem. We're going to add. Now, the review doesn't work if I'm the one doing all the talking. I'm not going to ask you to do the problem, like tell me exactly what you wrote, but I need an idea on how to do it. So for this problem here, we are adding 3 decimals. What is the key to adding decimals? What is the key?
Decimal point spot?
Perfect. So align decimal points. All right, so 34.6, 2.38, and 0.0429. So from here, I'm going to go ahead and fill in the blanks with zeros. And now I just add. So I get a 9, 2, 8 and 4 is 12. Carry the 1. 1 plus 6 is 7, plus 3 is 10. Put my decimal, carry the 1. 1 plus 4 is 5, and 5 plus 2 is 7. And a 3. All right, so the final result would be 37.0229. Does that make sense, everyone? Okay. All right, so here's another example. All right. Now, I'm adding -6 plus 91. These are integers, okay? So both numbers are integers. All right, both numbers are integers. And what rule am I going to use? Rule number 1 or rule number 2?
Number 2.
Very good. I'm going to use rule number 2 because the signs in front of the numbers are opposites. So, just so we can review, remember, you take the absolute value of each one of the numbers and you label the larger one. Then you just subtract the smaller number from the larger number. Here I need to borrow. So I get 85. Now, the question becomes, is 85 positive or is it negative? You look back into the absolute value. And whatever the sign is in front of the number, that's the sign you use. Since the 91 is positive, my result 85 is going to be positive as well. So -6 plus 91 equals 85. Does that make sense, everybody? Good, 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 good. Am I moving too fast? Are we okay? All right, good, because I am going to speed up. No, I mean, I'm not going to speed up right now, but I'm going to move a little bit faster than normally. So here's our next example. So we have -4.717 divided by positive 0.53. So let's do the easy part first. We know these are integers. They have signs. We're dividing. So the easy part is, what is a divided, or what is a negative divided by a positive? Very good. So I know my answer is negative. Like, I know it's negative. Now that I got rid of the negative, or now that I have established that, let's go ahead and divide the numbers. So remember, the denominator goes in or outside the house. The numerator goes inside. Your divisor, which is that number on the outside, since we have decimals, it must be a whole number. So in order for me to make 0.53 a whole number, I have to move the decimal 2 places to the right, which means in my dividend, I also need to move that 2 places to the right as well. So I'm going to rewrite my problem. I'm going to place my decimal appropriately. I'm going to copy it into the quotient. And now I don't have to worry about anything regarding the decimal point. The decimal point is over. The only thing I got to do now is just divide. All right? So 53 goes into 471 8 times. So that's going to give me 424. Now I need to subtract 471 minus 424. That's going to give me 47. And I drop down to 7. Okay? Now I ask myself, how many times does 53 go into 477? So I got to do this again. So let's see here. So I think it's going to be 8 again. So 7 minus 4 is 3. 7 minus 2 is 5. 4 minus 4 is 0. And now I can see... Oh, sorry. I forgot to write a 0 and drop it down. Now, 53 goes into 530 how many times? Wait a minute.
Wait.
I think, yep. Hold on. Got a little bit of a math error here. I didn't add correctly in my head. That's going to be 9. That's going to be a 9. I thought, when I added, I got one too many, so I thought, oh, that's too much. Sorry about that. 53 goes into 477. Exactly 9 times. When I added in my head, I got 476, but stupid me. So my answer is negative 8.9. Okay, are there any questions there? Any questions there? All right, so far so good. First and foremost, 12 to the second power. What does that mean? Before you even do the problem.
12.
Good. And 12 times 12 is 144. The key to this was understanding what an exponent is. Okay, are there any questions? All right, let's keep going with more of these problems. These are all simplifying problems. All right, so we have negative 25 plus 17 plus negative 13 plus negative 21. Is there anything about this example here that kind of sticks out at you?
The parentheses.
What about them? I agree.
Do we do those first, I think?
Okay, I'm okay with that. But Preachy, when you look inside the parentheses, it's only a number. So there's nothing you can do in there. But there is something around the parentheses that is jumping out at me. Somebody help her?
The plus and the negatives are back to black.
Yeah, do you see these plus and negatives? They are back to back. So, recall, and I'm going to write it off to the right-hand side here. Remember that multiplying or dividing integers? All right, I don't know if you remember this little table that I gave you, but this actually helps you when you have two signs that are back to back. So I have a plus and a minus. Well, that's going to be row number 2, and that result is going to be a minus. And then if you look at that 21, you have a plus and a minus back to back again. So that's going to be a minus. So the first thing I'm going to do is I'm going to rewrite the problem. And instead of writing plus negative 13, I'm just going to write minus 13. And instead of writing plus negative 21, I'm just going to write minus 21. In other words, I took care of those signs first because they were back to back and it annoyed me. Now from here, we can just go left to right. So negative 25 plus 17 is negative 8. Minus 13 minus 21. And what's really nice about this is if you look at the 8, the 13, and the 21, they all have a negative symbol in front of them. So what I'm going to do is come over here to the right. I'm just going to combine them. I'm going to add them all up. So 1 and 3 is 4 plus 8 is 12. Carry the 1. 1 and 2 is 3 plus 1 more is 4. So I'm just going to combine them and keep the sign. So the answer is negative 42. Are we all on the same page so far? All right. All right, now the next problem, we're going to run into that double sign issue again, but this one's going to be just a little bit different. So here I have 6 times negative 3 minus a negative 12. So like I said, once again, we run into this double sign back to back. It's right here at the very end. Now, when I look at that, I have a negative and a negative, and I know that is going to be row number 4. Hey, can I ask you a question? Could you hear Artie in the background chewing on a water bottle? All right, give me 1 sec.
I couldn't hear it till you said it.
All right,
You couldn't hear it.
that's okay. I'm gonna fix it real quick. Hold on. All right, well, I couldn't pull it out of his mouth, so hopefully he doesn't bite down too hard on it. So, once again, we'll go back, we'll review this. I got the double negative back to back. That's going to be in row 4 above in the upper right-hand corner of your viewing screen. So, I'm going to rewrite the problem as 6 times negative 3 plus 12. Now, from here, order of operations. So, I got to do the multiplication first. 6 times negative 3 is negative 18 plus 12. And I think we can kind of do this one together. Negative 18 plus 12 is going to be negative 6. Okay, are there any questions so far?
So that negative 3 isn't a negative back to back, too.
Okay, so before I answer that question, I'll zoom in. Where do you see the negative in front?
Okay, so the negative 3 doesn't go with the sign to the right.
No, it's always the sign in front.
Okay.
Okay? Good question, by the way. All right, let's do another one. And we're going to piggyback off this idea of the order of operations. All right, so we're going to simplify, and we're going to use our order of operations. Now, just to review them, the order is parentheses, exponents, multiplication and division, addition and subtraction, but I'm going to put them in a box and write from left to right in order. Okay? All right, so remember, multiplication and division, you go left to right in the order in which they appear. So, here I need to start with the work inside the parentheses. More importantly, the 3 to the second power. So, this is going to be 5 plus 9. And then I write everything exactly how it looks. I do not do two or more steps at once. I like to keep it simple. So now, I still need to do the work inside the parentheses. So I'm going to add 5 and 9 together. And that's going to be 14. Okay? From here, I notice there are no more parentheses. So I can scratch it out. Now I need to do any remaining exponents. That would be 3 to the second power, which is 9. Now that there are no more exponents, I'm going to do multiplication and division from left to right in the order where they appear. So I'm going to do 14 divided by 7 first, and that is 2. And now I'm going to do 2 times 9, which is 18. Does that make sense, everyone? Are there any questions so far? All right. So our next example, we are still simplifying. So we have to add or subtract 9 over 7 minus 7 over 12 minus 1 over 6. So how would I do that?
Can we do it long ways?
What do you mean by long ways?
Would you find the least common denominator?
I would have to find the least common denominator first. Excellent. Now, how would I do that? And here, like, this is where we need to just take our time. All right? So how would I find a common denominator between 7, 12, and 6? Any ideas? All right. So have no fear. We can always go back into our notes. Here's what we're going to do. We need to find the LCD. To do that, I'm just going to go ahead and just try to prime factorize these numbers. That's it. So 7 is just 1 times 7. It's a prime number. Nothing changes there. 12 is going to be 2 times 2 times 3. Now, if you're wondering how I got that, in the upper right-hand corner of your screen, what I did is just broke it down using that prime factorization tree. And I circled my prime numbers. And then 6 is going to be 2 times 3. So my LCD is going to equal the product of unique prime numbers. Now, 1 is not prime, so you don't include that one. 2 is prime, 3 is prime, and 7 is prime. The question becomes, what are the exponents? So I'm going to look at the number 2 first, and I find the maximum number of 2's in any one of the prime factorizations. So in that number 12, I actually have 2 of the 2's. That's the most. So that's going to be 2 to the second power. Now for the number 3, I only see one number 3 in the factorization of 12. and one number 3 in the factorization of 6. So that's going to be 3 to the first because I'm looking for the maximum number of times in one factorization. Lastly, the 7, I only see it once. So right here is the prime factorization of my LCD. The only thing I need to do is just multiply it out. 2 to the second is 4. 4 times 3 is 12. And 12 times 7 is 84. Adding or subtracting fractions is going to take us the most time on this test. Okay? So that's the first thing I do. Second, we're going to build equivalent fractions. Okay? So what that means here is this. I need to take that 9 over 7. I need to multiply it by a number. Excuse me. So that whatever number I multiply 9 over 7 by, I'm going to get 84 as a denominator. That number is going to be 12 over 12. Because 7 times 12 is 84. And remember, whatever you do to that denominator, you got to do to the numerator. You're only allowed to multiply by a fancy looking 1. And that's exactly what I did there. 9 times 12 is 108. So there's my first equivalent fraction. Now I need to do that for the second. Same thing. I want a denominator of 84. My first fraction I'm starting off with is 7 over 12. So the number that I need to multiply by is 7. So I multiply 7 over 7. And I get 49 over 84. All right, the last number is 1/6. I know I want an 84 for a denominator. So I'm going to have to multiply this 1/6 by 14 over 14. Does that make sense so far, everybody? So I get 14 over 84. What I'm going to do is take each one of these equivalent fractions and write it directly below. So the 9 over 7 is 108 over 84 minus the 7 over 12 turned into 49 over 84 minus the 1/6 turned into 14 over 84. Since I have a common denominator now, I write it once, and I just write out my numerator. I know my answer is going to have an 84 in a denominator. The question becomes, what is 108 minus 49 minus 14? And the answer to that is 45. And then our denominator, like I said, is going to be 84. And before I circle this answer, what do I always have to check? What do I always have to check?
If it's simplified all the way.
Exactly. Is this simplified? All right. 1 second here. There we go. So the easiest way to do this, I hate to say it, you got to prime factorize it again, just to make sure. Now, what's nice is you already did you see me circling it in the middle of your screen. You already did the prime factorization of 84. 2 times 2 times 3 times 7. You already did that one. 45 is 5 times 9. And then that 9 can be broken down into 3 times 3. So we have a 3 times 3 times 5. The only thing we're looking for, numbers that are the same in the numerator and denominator. And there's only one. It's the 3. So I can reduce the 3. And what's ever left over is your result. Just multiply. 3 times 5 is 15. 2 times 2 is 4. Times 7 is 28. So, that was by far the longest problem that we've done. I think that's why students, they just hate fractions, because it takes the most time. And I'm with you. Now, if we were just strictly speaking about a test, I wouldn't be saying what I'm about to say. Here's what I'm going to tell you. There are 60 questions on this test. 60. If you come across a problem that you think is going to be really difficult, skip it. Come back to it later. Okay? All right? Just skip it and come back to it. Now, I'm going to show you this just so you can see it before we move on. I am just pulling these problems off the practice final exam. If you skip a problem, you can always click right here in the middle where it says 24 of 60. You can always click there, and here's all the questions. So, like, for example, all right, real quick, which one did we just do? No, we did. Was it this one? 9 over 7 minus 7 twelfths. Oh, plus 1/6. All right, well, we're going to get the wrong answer anyways. It doesn't matter. So, even though it's going to be a different answer, and that's fine. All right? Watch what happens here. That was problem 19, just so you know. If I look down at problem 19, now it has that symbol right there, which means, okay, you did this problem. All right? So if you skip a problem, remember, all you have to do is come into the middle here. All the ones you did will have this little symbol. All the ones that you didn't do will have nothing. So like question 1, we didn't do that one. So that's why there's no symbol. Does that make sense? Because this is a timed test. Okay? I don't want you to waste too much time on a problem that, let's be honest, you might get incorrect anyways. Get the ones that you know correct first. Get them out of the way. Then come back. All right, what time is it? 10:49? All right, let's do one more problem. Oops. 5 over 22 times 1/2 times 11 over 10. Now remember, when we multiply fractions, and we did it up above, you want to simplify first. And then you want to multiply. What I mean by that is this. I'm going to look at the first fraction. 5 over 22. 5 is prime. I'm going to rewrite 22 is 2 times 11. Times 1/2. Nothing changes there. Times. The third fraction, the 11 is prime. But that 10, I'm going to rewrite as 2 times 5. Now, I'm just going to write one big numerator, one big denominator, and put them all in order. And the reason why I can do that is because I am multiplying. So I get 1 times 5 times 11 for my numerator. My denominator, I have three of the 2's. 1, 2, 3. A 5, and an 11. Okay? So far, so good? Notice I didn't do any multiplying yet. All I did was simplify things. Now I'm going to look for numbers that are the same in the numerator and denominator. So I can reduce the 5. I can reduce an 11. Since there's nothing else I can do, now I finally multiply. I have a 1 in the numerator, and 2 times 2 times 2 is 8 in my denominator. Okay? So, once again, before we leave, I'll show you. I'm going to hit 1/8. And I don't know, I just hit the enter button. I guess you can hit this button down here, for the next problem. But remember, that was question 24. So if I scroll down, 24 has a gold circle next to it, which means I did that one. Okay? So just like I said, there's 60 questions on your final. If you get bogged down with one of them, I say skip it, move on to the next. I'd rather you answer 45 questions I'd rather you answer 45 questions that you know versus 30 questions where you spent too much time on some of them and that's why you couldn't get to the other ones. Does that make sense, everybody?